Hello. So I've been working on some buck boost type circuits or buck regulators, and I realized I needed an electronic load. Now I was actually making some videos on how to develop these circuits and making PCBs for them and all that kind of stuff, but I run into a snag. The one chip that I actually recovered from a PCB doesn't work. And so I've got some on order, but I don't know when they get here, maybe in a week or two. So I thought in the meantime I will evaluate or review this electronic load that I bought in order to test the circuits that I am building. In any case, this is what I ended up with, but what I originally looked at, I saw a video by another YouTube channel, and they were using one of these BK Precision electronic loads, and I kind of liked the looks of that one. I thought it looked simple. It had some, simple buttons on the front there and stuff. And in any case, I thought, I wonder how much these things are. And I was surprised to find out how expensive these things are. I thought BK Precision was reasonably priced. I got one of their little oscilloscopes which I bought 15 years ago. But that's not going to work, and this one here is only 150 watts. If you want more wattage, you're looking at $1,700 or maybe more. And there are some cheaper ones. Siglent makes one, I think just 800 and something dollars and so on. But I thought, well, let's have a look at my friends at AliExpress, and I found this thing here, which actually has more features than I even need. It's an ET5410A Plus, and it's got on there East Tester. That's the brand of it. In any case, it claims to have all these features here: 400 watts, up to 400 watts, 100 up to 150 volts, 40 amps, and including some features which some of the others may not even have. It has a battery test function there, and it has a couple of extra modes, CC plus CV and CCR plus CV. We'll discuss that. It's got an LED circuit test, and it's got a scanning and a list test, but that's more for people that are putting this thing on a production line somewhere, and they can do some automated tests or connect remotely to it with a computer. But in any case, short circuit, dynamic test, whatever. This one only has a USB port, but the one I got sent actually has the additional RS-232 and a bunch of signals on the back. There's different models of it. There's a dual channel one, but this is the single channel that I got. So the specifications here, the ET5410A Plus is what we have. It's got single channel, 400 watts, 0 to 150 volts, and 0 to 40 amps. And it has two different ranges that you can select, 0.1 volts to 20 volts basically. And then it has 0.1 to 150 volts. But in that, in the 150 volt mode, it does up to 3 amps if you're at 150 volts, because you can kind of work it out. 3 times 150, it's got 400 watts. So, but when you're in the up to 20 volts, you can do up to 40 amps. And well, it claims to be up to 0.1% accurate plus 0.5%. I think FS might be full scale or something. I don't know what that actually means, but anyway. So I thought, well, that sounds pretty good. That's what we need. So I ordered one and I've received it. So it came with a manual. So let's have a look at that first. Okay, so this is the little manual that came with it. It is quite readable, not as bad as most Chinese manuals are concerned. It's been reasonably well translated. There's a few words in there that maybe one might choose to use differently, but they are obvious, so you know what they're talking about. So this is just an explanation of the front panel, what the buttons do, and so on. Some of the buttons have two modes where you hold it down for an extended couple of seconds. It does something different than if you just push it by itself. That's all explained in here. They call that a long press function, you know, when you hold it down. And explanation of the system menu. We're going to go through all those things, so there's no point in discussing that in any detail here. Different modes, constant power, constant resistance, etc., etc. There's one mode here that we will also look at, but that's kind of one of the extended modes that it has. Let me zoom in a little bit there. So they give some descriptions here, like there is a dynamic test operation, they call it, and you actually have two settings that you can change, either a voltage or current, that you can constant voltage, constant current mode, kind of basically, and you have two settings. So the example here is 5 amps and 10 amps, and then you can set a timing. You might want to turn it on for 1 second at 10 amps, 2 seconds at 5 amps, and so on, whatever. And you can choose whether you just want to do it once or whether you want to continuously change it. And they call that actually on the menu on the device itself, they call it a transient mode, because obviously you can put a oscilloscope on the device on the test, and then you can see what if there's any transients, you know, how long before the power supply responds, and if there's some undershoot and whatever. So that's an interesting mode which is discussed here. Alright, so there's nothing much else here. It has some modes there to do with if you got a remotely connected, you can do some a range of tests and actually store the results in the device, and then you can it'll display it as a list. You can probably download it through the USB port, I presume. I haven't really read up on that because I don't plan to use that feature at all. Battery test operation, we will look at that in detail. It has an LED test operation. I gather that that is for testing power supplies to drive LEDs, because you know probably that LED power supplies, they might run like 12 volts and they expect to have a whole bunch of LEDs attached to them, or a higher voltage, and LED power supplies tend to be constant current supplies, so they actually adjust themselves according to how much current is drawn, and they would have specialized test properties, so you can actually use this LED test operation to test those kind of supplies. I gather that is what it is for. I don't build LED power supplies at this point, so I'm not going to test that myself until I ever come to a position where I need to do that. And you can test short circuit operation and some information here on how to set up the communications. If you at the back of it, there is a socket there that can do RS-485 and RS-232 and so on, and the USB port. If you got one of those software packages that has that SCPI, Skippy they call it, interface, so it has those functionalities there. Okay, so when it comes to electronic loads, you got to understand kind of how they work. Internally to the electronic loads, you would have a big heat sink with a fan attached to it that sucks or blows air over it to cool it. And connected to that heat sink, of course, would be some transistor-like devices such as MOSFETs, IGBTs, whatever they choose to use. And these devices, of course, can be adjusted to pass more or less current through them. And this is what you got to keep in mind with these different test modes that it has. There's constant voltage, constant resistance, constant current, and constant power. And since the device can monitor its voltage and the current that is actually running through it, it can therefore also determine what the resistance is. So if you select constant voltage mode, it will adjust the current through the electronic load in order to keep the voltage at a steady rate. If you select constant resistance, it will monitor the voltage and current, and again will adjust the current in order to keep the resistance steady. And if you select constant current, it monitors the voltage and calculates the resistance, and it will then be able to adjust the resistance, if you like, of the internal MOSFET or whatever it is using in order to keep the current steady, so it can increase or decrease it. And similarly with constant power, it monitors current and voltage, so therefore again it can adjust its current in order to keep the power steady. So given that a electronic load is actually just sinking or consuming power, we are going to be attaching a device under test, and the initial test we will just going to use our benchtop DC power supply, and I'm also going to connect a digital voltmeter, which you will see at the top right hand of the screen will be displayed as a value that it is reading. Now, an interesting fact about this is that at the currents that we're dealing with, because you know it's an electronic load and we are mostly testing power supplies, the current running through these leads from the device under test and to the electronic load are going to have some resistance, and normally that doesn't really matter too much, but if you're running 10 amps or 20 amps or something, even a very small amount of resistance is going to make a difference. And as you can see from Ohm's law over here, that the voltage is equivalent to current times resistance. So if you're drawing 10 amps and the resistance of your wire is 0.1 ohm, then you're going to have 0.1 times 10, which is a volt. So therefore, if this is outputting 10 volts, you're only going to see 9 volts at the electronic load, because 1 volt will be dropped through the leads, and similarly the amount of power that is dropped to the leads is also significant, so the power amount that the electronic load will display will be less, and so it goes on. So what you will see when we go and look at the actual device, it actually has a calibration function which actually passes a very small amount of current. These are programmable through these leads. It reads the voltage, and then it passes a larger amount of current through these leads, and then it reads the voltage again, and from the two different readings it can actually determine what the resistance of these wires is, and it can actually make an adjustment on the display So you can actually therefore tell it by turning this feature on and off. You can tell it to display the exact voltage at the load or the exact voltage at the device under test, which sometimes you want to know this and sometimes you want to know that. And therefore that is why we have hooked up a digital voltmeter to the electronic load, so we can actually see the actual voltage that the electronic load is seeing, and if we calibrate it then we can see these two values. Now the value on the digital voltmeter will also be slightly different from the one on the electronic load, even if both of them are very accurate, because the leads to the digital voltmeter also, and in my case here in my setup here, I've got very long leads going from the voltmeter to the electronic load, so there's going to be a slight difference, but it'll probably only be 0.01 volts or something like that. But you will see it, but that is expected as well. So in any case, let's go to the actual device and see what features it has. Okay, so this is the device. We're going to go through what these various buttons do, like this mode, there's a menu, set, and so on. These are explained in the manual, as you saw, so I don't really need to go through those, they're self-explanatory. There is on the screen here, underneath the screen, constant current, constant voltage. So you can select these different modes quickly using those two buttons, because they are the most common modes that one tends to use. These two buttons here, you can still click while it is running. You can push these in order to make a quick change to the current or a quick change to the voltage. So you don't have to stop a test. You can actually make some adjustments as you're going along, which is good. And it has a menu for settings, which looks like that. Item number 1, load set. This is for setting the general parameters for that covers all the different tests that it does. Trigger manual, we're not going to go into much detail there, but this thing can be run remotely through the RS-232 interface or USB interface, and if you run it remotely through some software on a computer, then you can change the trigger to remote, but this one we're not going to do that, so manual is through the keyboard here. Offset voltage is an important one. I've got it set to on. This has to do with the calibration, so you'll find that there will be an offset, a difference in the voltage measured at the load and the source, because it's connected via wires, and the wires have resistance, and some voltage will be dropped there, especially at high currents. So we can do a calibration and select which we want to see, the voltage here or the voltage there. Up the top on the screen there, on the right hand top, you'll see there is a voltage displayed there that is actually connected to these cables here with these Kelvin clips on it, to a digital voltmeter, and so we can actually see what the digital voltmeter says and what the load says of the voltage. There will be a difference between the two, because the digital voltmeter has very long leads on it too, so it'll also actually drop a tiny little bit of voltage. In any case, that's for the test. Okay, so it has two ranges. You can set the current to low, which is what I have, what it is currently set to, but we actually want to set that to high, so that we can actually have a current more than 3 amps, because it is a 400 watt device. Now they allow a little bit more, 410 watts, but as you can imagine, if we are going to be at high voltage, we don't really want to have 42 amps at 155 volts. It wouldn't allow that. So therefore I tend to set the voltage range to low, like so. So now we can do, is a safe way to deal with it. We can do up to 21 volts and up to 42 amps. Because most of the testing I'll do will be less, 21 volts or less. So, and I can always change that if need be. So these values here, 42 amps, 21 volts, 410 watts, you could actually, these are going to be the defaults on some of the tests you'll see, and you can actually change those according to the test that you're doing, which would be recommended, because if you're doing a test on a 5-volt device, you wouldn't ever want this thing to be able to do more than 5.5 volts or something like that. So anyway, so that's what these general parameters are for. And system set, that is just some generic little settings there. Language is English, whether you want the keys to make a tone, and factory reset, and so on. I haven't changed those. Com set is for the communications interface at the back. As I said, it's got RS-232, you can set baud rates and stuff. Not going to go in there. So this, one of the modes that it has is it can actually do a kind of a bit of an automated test. It's a quality test, they call it. So you can provide a starting voltage and a ending voltage, a starting current and an ending current, a starting power and an ending power, and it will use these values to do a complete test, and it will give you the information, the results, on a little table on the screen here. But I'm not going to be using that. That's more for professional use, I guess, if you got to prove that a particular device is qualified, you know, quality, the results that you want. Okay. System info is just the model number, the serial hardware version numbers, firmware versions. There is also a load effect test, and in this particular test you can set up the 3 values, and it is defaulting to 100 milliamps, 50 500 milliamps, half an amp, 1 amp, and it has a steps time of 5 seconds. So it's going to go through these different amperages, and then it records information like what is the difference in voltage at the device on the test. Of course, when you draw these different currents, and of course these are editable, and then it tells you the resistance in milliohms and some percentage there. I'd have to look in the manual exactly what that pertains to, but anyway, that is also a kind of a more complex test. These are those 3 values that I'm talking about. See, 42, 21, 410. You remember it came from that load setting menu, so you can actually edit them there, so they always come up like this, or you can actually edit them here. you'll be able to select these different values. See, there you go. When they're light blue like that, I don't know if you can see it all that well on the camera, but that's very clear to me. These are actually gray, and this is actually like a cyan color. They it isn't actually editable then. In any case, let's talk about this first. Key definition. You can actually change the function of some of the keys on the little keyboard here. Maybe you use a particular feature more often than others. You can actually reprogram some of the keys there to do those things. Compensation, we're going to be looking at. This is, as I said, for whether you want to measure the voltage at the load or at the source. It compensates for the resistance in the connections. And normally, if you got short leads with very low resistance, you probably shouldn't see much difference, but in this case we are going to see a difference, because this is actually a pretty crummy sort of lead on purpose, so we can see what happens. Pin definition is for at the back of the device there is like some little pins that you can connect to. Again, that is for if you're doing remote tests. It can actually store results from automated tests in a list, and you can actually pull the list out. I think you can probably download it or something to the USB interface. I'm not sure. I haven't really looked at that feature. I'm not planning to use it. That's what that's all about. And there's a help page there, but I'm suggesting the manual will be better to use than the help there. Okay, so let's turn on this power supply. And I've got the power supply set for, it's going to be hard to see for you guys there, but it's set for 10 volts, 2.1 amps right now. So I'm going to escape here, and we're going to go constant current. I've got it set for 2 amps, which is a little bit lower than what the power supply is going to be able to do. You can actually select here how long the test should be running, so you can put that in there. Again, as I said, there's those limits over there. I'm not going to touch those right now, because I'm not in danger of anything going wrong, because both of these devices have protection built in, so there's nothing is going to happen. Okay, so constant current, and I'm going to push the on button, and I'm going to push the on button here too. Okay, so this is set for 10 volts, and it is reading 2.011 amps. This one is displaying 9.8134 volts, and it is recording 1.99 amps. And as you can see at the top of the screen there, the readout from the digital voltmeter is actually 9.837. So that's kind of agreeing with what the load is reading. The load has a little bit better connection to the or a worse connection, I should say, to these crappy crocodile clips. These Kelvin clips make a much better connection, so that's why you'll see a slight discrepancy in that voltage, but it's pretty accurate. But as I said, let's say this is the voltage that we are recording at the load, but let's say we want to see what the voltage is at the source, and this is where that compensation comes in. So compensation and enter, and so now you can change these values. If you know, I'm not going to change them, but it might be more accurate if I did change them, but it's good enough to show how this works. I've got it's going to be drawing a half an amp first. It's going to do a voltage reading, then it's going to draw 1 amp. It's going to do a voltage reading, and then it is going to, from that it can actually determine between the two, just using Ohm's law, what the actual resistance of the wire here is, and it will make an adjustment, as you will see. So I'm going to press on. It'll be very quick, you will hardly see it. Okay, so now when I go back to constant current, you see what happened? Now it is actually giving me not 9.8 volts like the digital voltmeter is still displaying. It's actually telling me 10.02 volts, which is what the power supply is actually supplying. So now it is actually displaying the voltage at the source, which in some cases that is maybe what you want to know about. However, I find that when you go to constant voltage mode, and I've got this set to 9.5 volts, and the display is 10, and on. Now it wants to drop the voltage, you see, in constant voltage mode to 9.5 volts, and in order to do that it wants to draw more current, but it can't because I've got this thing set to 2.1 amps. So as you cannot, if I move this, you'll see maybe that the little light here is on. This is constant current mode on the power supply, which is saying, hey, somebody's trying to draw more than 2.1 amps, and it's capping it at 2.1 amps on the power supply. So therefore, but it is saying 9.7 volts, but look at the top right hand of the screen, you see 9.5 volts. That is the voltage at the load here, but it is displaying the voltage of the power source. So therefore you might be thinking to yourself, hey, what the hey, but I've got this set to 9.5 volts, but it's gone to 9.715. Well, if we turn this off and we go back to the menu, and I'm going to go to system set, and I go, oh, sorry, that is not what I wanted to do. I actually need to be in load set. Hard to remember something. And let's turn the offset voltage off. Okay. Now we go to constant voltage mode, and we're going to say on. And you see now it is displaying 9.5 volts because that is the voltage at the actual load, and that it is triggering on the 9.5 volts. So that's what I'm saying. Sometimes you want to know, and the voltage at the source is 9.69, it says here, but the yeah, it is actually producing 9.69 volts, and it's capping the current at 2.1 amps because that's what I got it set to as the maximum current that it can produce. So it is actually working and doing the right thing, but you got to know what you're looking at, and that calibration mode, as I said, is therefore important. Sometimes you want it on and sometimes you don't. It all depends on what you're trying to, what is important to you, the voltage or whatever at the source or at the load. Okay, so that's the constant voltage one, and you can actually set the voltage, and that's just how it behaves. If I up the current on this one, you will see that the current will go up, but the voltage will stay the same. I wonder if I got to shut it down, or if I can do that while it is running. I think I can do it while it is running. So let's, yeah, there you go. So you got set to 2.5 amps now, but the voltage stays the same. It's just drawing more current, and of course more power. So that is what constant voltage mode does. It just keeps the voltage steady, and it will adjust the current to keep the voltage steady. Okay. So, oh, I hit the wrong button again. I didn't want to go to menu. I want to go to mode. Alright, so constant power. So I've got this set to 12 watts, and you see when it's not drawing any load at all, it is actually reflecting the same voltage here as it is on the power supply. Exactly, because there's very little current flowing through that wire over here, and as you see from on the screen, the top right hand corner, everyone says 10 volts. It's only when you actually turn it on and you start drawing power that the resistance in this wire here will make the voltage at the load different from the source. I know I keep on harping on about it, but it's important that that's understood. Alright, so we can turn that on, and now as you can see, it is keeping the wattage steady. Now it is drawing actually 12 watts according to the power supply, and that's what we got it set for, but it is saying 9.892 volts, and according to the digital voltmeter that's correct here. But again, we can actually, if we turn the calibration back on, see, now it has worked out how much this cable is losing. Some power is being lost there, and it is making up for that now. So it says, okay, it is 12 watts, and that's correct. And the voltage at the source here is actually 10 volts, and the voltage at the source is 10 volts. So again, showing how the calibration mode, when you turn the voltage offset on and off, what that is all about. As I said, sometimes you want to know, quite often actually, you want to know what losses there are in the connections. So, but sometimes you don't, and so you need to know what that's all about. So we won't go into that any further, and I'm actually going to go to turn it back off again. There we go, for the rest of the tests. So we can keep that in mind, what that's all about. Alright, so mode, that constant power mode is actually quite useful and powerful, because think about it, if you got a little device that you want to test, like an IoT device or something, and it's running on a battery, you might want to test how much current it is drawing, how much power it is drawing from the battery in sleep mode, in standby mode, and full on mode, or whatever modes it has. So you can actually calculate if the battery size, how long it's going to live, and all that kind of stuff. So again, that's where these electronic loads come in. They're important for those kind of calculations. All right, and then we got constant resistance, which is an interesting mode. So you can set the resistance here. Now let's have a look. We are at 10 volts. If we had 10 ohms, we would be doing 1 amp, wouldn't we? So let's change that to 10 ohms. So in order to do that, I hit enter, and now there's like a little yellow thing there that shows you the digit that you can change. That's 10. Hit enter again, and when we turn it on, yep, it's drawing because the voltage at the load here is actually 9.913 volts. It's drawing 0.98 amps, but at the source it's actually showing 0.996. But it is close, and it is actually the actual resistance that it is using is 10.13. It's a little bit sort of, it's close, and it is burning up 9.7 watts. But because there is some power being burnt up in the cable, the actual power supply is actually 9.96, a little bit higher. Anyway, that's what constant resistance is all about. Turn it off. Now these modes here, CC plus CV, they are enter. They have two values that you can program. You can tell it how much current to draw, and you can actually give it a voltage value. If that voltage here, if the voltage on the source is not that high, it will not draw any current at all, I believe. So let's try that. Yeah, you see it highlighted constant voltage, went red, so it is not actually drawing any current. So what that actually means is that let's say that you are discharging a battery. Not that you might want to use this actual mode. It has a proper battery mode, which we'll go into later. But for argument's sake, let's say that that's all you want to do. It's a lithium-ion cell, and you want to discharge it until it reaches 3 volts. You could set 3 volts here. You could tell it to discharge maybe 1 amp or something like that, and then you can let it run, and as soon as it reaches the voltage, it goes below the voltage there, it will go to this constant voltage mode. It's a little bit of a misnomer. It's really like a trigger voltage that actually says, okay, when it reaches that voltage, turn off. So that's what that does. So if I want to, if I change that voltage here, to make sure that you see what I mean. Let's use this knob here. There, 9 volts, saves me having to go to the digit. Okay, so now if I turn it on, you see it's happily drawing 2 amps on the source and 20 watts. But now if I change the voltage on this device here, you see what happened? It went to 9 volts, and if I turn the voltage back up, it will actually it goes into a mode where it will actually start drawing the maximum amount of current. So you really have to make sure that you set this limit here. I don't know, they all do that. This is not unique to this one. I have checked it out. There are other models of electronic loads and they do the same thing. I do not know why that is. You would think that if the voltage goes back up, you would want it to resume where it was, but it doesn't. It will allow it then to draw more than 2 amps, you see. So you have to keep that in mind. So, but of course that's not going to happen if you're discharging a battery. The voltage is never going to go back up again. So anyway, not 100% sure where I would ever use such a mode, but when you need it, you will know it. Alright, and so therefore the other mode over there, the constant resistance mode, does very much the same thing, but now you can put a resistance in there, and again it has, you can tell it how much resistance and a voltage, and if it goes below that voltage it'll switch off. But if the voltage goes back up again, it goes into that same mode. It starts to draw the maximum amount of current that the limit is set to. Alright, now this mode here is the transient mode. This can be useful. It is actually going to switch between these two values. If I hit set, you can actually edit some of those. There are different modes: continuous mode, there's pulse mode, trigger mode is when you're using this remotely and you can trigger it. There's pulse mode, presumably, I haven't tried this, presumably it'll only do it once. And there's continuous mode, and you can actually tell it if you want it to be constant current or constant voltage. Leave it on constant current. Value A, here you can actually edit those values as well. And you would be able to edit them here too, probably. Are you able to, or do you have to go to the menu? No, you can't edit them here. You have to go to the settings menu. In any case, this looks good. Let's try it out. It's going to go 2 amps for 1 second. Then it's going to do 1 amp for 2 seconds. Then it's going to do 2 amps again. So let's have a look what happens. Now, if you hook this up to an oscilloscope, the load here, then you'll be able to see the transients and see if it's overshoots, undershoots, whatever. Whatever side effects that has, so you can actually test to see what the response of your power supply or whatever it is at various loads when it switches. This can be important. Okay, 2 amps, 1 amp, 2 amps, 1 amp, You can see it changing on the power supply. Now I don't have the oscilloscope hooked up, so you'll just have to believe me. Okay, so that actually could be quite useful. All right, now list and scan we're not going to go into. These are for, as I said earlier, for if you got a production line and you got this thing hooked up to do some automatic testing, and it'll save the results in a list, and you can look at them. I don't plan to use those features. Short. So it is going to emulate a short circuit. Now these limits are going to be important then, because you wouldn't want to, whatever device you're testing, I don't have to touch these because this DC power supply is completely protected, and I've got it set to 2.5 amps now maximum, and 10 volts, so it is not going to allow it to draw too much current and stuff. But if you have a power supply that you've designed or that you have and it actually has short circuit protection, this would be a way to test that. So as you can see, I've got it set for 2.5 amps, but the power supply has actually reduced its voltage to 0.29 volts. But of course, because of the voltage drop in the cable, it's saying 0.53 volts here. But if I turn the calibration on, you would see those values change. You've seen that before, so I'm not going to do that right now. So that is what that's all about. And the power supply, you can see it's maxing at the 2.5 amps because that's what I told it to set as a limit. It's over here. All right. Now battery mode. We're going to hook up a lithium-ion battery and show how that works. So give me a second here. Okay, so I have a lithium-ion cell over here, and its voltage with no load is 4.082 volts, and it's got some really wimpy little wires coming out, and those things actually get hot even when you draw 2 amps, so they're going to have some resistance, all right, which means that as soon as I start drawing current, you will see the voltage drop quite a bit, which would be higher than the actual voltage drop on the cell itself, but that's actually useful for our tests. So there are different settings you can actually choose for the battery mode. You can select constant current, constant resistance. You can select a cutoff either on voltage or time or energy, watt hours, or capacity, amp hours, or voltage. Okay, so that's quite flexible. If you want to see how long it takes before a certain amount of power has been consumed and so on, you can change these values, but we're going to keep it on voltage. I am going to, it's currently set to 3.65 volts, and we're going to leave it at that. I've got it, you can actually put up to 3 different voltages if you for some reason want to draw 1 amp or 2 amps, let's say, for until it reaches that voltage, and you then want to switch it to 1 amp until it reaches, let's say, 3.2 volts. I'm just making this up, so I'm going along, I don't know. Then you can also say, okay, go to 500 milliamps when it reaches 3 volts, and then there will be a cutoff voltage there, and then you say I don't want to go lower than 2.95 volts or something like that. So you can actually do it in stepwise. Certain batteries or something maybe need to be treated that way, I'm not sure. All I deal with is lithium-ion batteries, and I can't see exactly why I would want to do that, but in any case, it's there. So I've got this set to draw 1 amp, and cutoff voltage 3.65 volts. It's currently 4, but as soon as I start drawing current, because of those wimpy wires and everything, the voltage at the load here will drop quite a bit, and if it reaches this voltage, it's going to stop. So normally, and it'll display how many amp hours and how many watt hours has been consumed. So you can actually use that in order to test the a battery to see how much power it holds and so on. So it straight away got to 3.65 volts. So I've got to lower that. That's why it didn't seem to do anything. It's an old battery I have salvaged out of something. I do not know. It's probably not a prime example of a good battery. No, actually, let's do this. Let's lower that voltage quite a bit so we can actually see what the voltage is when it starts running. .2 volts. Okay, see, now it is running. It's drawing an amp, 3.54 watts. Voltage 3.5. So if we set the cutoff to 3.57 or something like that, or 3.56, we should see it stop at that rate. So let's try that. What did I say? 3.56? Already forgotten. Boom. There it went. You see it reached 3.56 and it stopped. And for that little time, 0.005 amp hours, 0.019 watt hours. That's how much energy was consumed at that rate. So I think that there is an LED mode. which I don't have any LEDs that it was designed for here. It seems to be set for 12 volts. That is what this thing can do, so it is quite useful, and you can safely test your circuits that way by setting the limits and what have you. And I thought I'd do a little review of it. As I said, I've been working on some circuits that I want to actually do videos on, how to design these buck regulators and stuff. So I'm waiting for some components to come in so I can complete that. But in the meantime, I thought I needed this electronic load in order to do testing. So I thought I would do a little review on it. And for what was it now, like $217 or whatever it cost, it's actually quite worth it, I think. And it's a lot cheaper than the brand name ones, and it does everything it needs to do. It is quite accurate and reliable, so that's that. In any case, I'll see you guys later, another video, and I'd really appreciate it if you could click the little buttons there to subscribe and to like and to do all those sort of things. And if you know somebody else that's interested in electronics and stuff, maybe point them to the channel. I need some more subscribers. I think I've got 400 odd or something like that. I need 1,000, so it would be appreciated if I can get a few more. Then I'll be recognized by YouTube, and that means I can do better videos. Might even get a little bit of money out of it just to buy better equipment so my videos can improve. That's wishful thinking. But as I said, I'll see you guys later. Bye bye.